On to example 2. Write the trig expression as one trig expression. Find the value of the expression. Okay, so the word expression's in here a lot, but what we're really being asked to do is use a trig identity so that way there's only one term here rather than two. Okay. So let's go over here and see what identity it is that we want. So what we're looking for here is cosine of 2 theta is equal to 1 minus 2 sine squared of theta. And so to come up with this, we would have had to have scrolled up to the very top, looked at our list of identities, and see if we could find anything that contained this. Okay. And this is actually the only one. Okay. And let's go ahead and apply this identity. Well, we should get cosine of 2 theta. Well, what is theta? It is pi over 2. Okay. And so that's just really cosine of pi, which is equal to -1. Let's try another one. Okay. This time we have a 2 sine theta cosine theta. Well, we also have an identity that contains that. Let's write down what that identity is. So sine of 2 theta is equal to 2 sine of theta cosine theta. And this is actually extremely useful for this example because these angles here are not ones that we're accustomed to seeing on the unit circle. It's not one of those common angles. So when we actually do go to use the formula, then we get sine of 2 times the angle you see there. So 2 times 22.5 degrees. And if we do that, that's going to give us sine of 45 degrees. And well, we know what sine of 45 degrees is. It's the square root of 2 over 2. And we're done there. All right, and example 3. And actually, before we do this example, I want to mention one thing, and that is we now have compiled a pretty big list of identities, and we're actually even going to do one more section with identities on it. So here in the near future, I'll put on Canvas a sheet that has all of these identities on it. Okay, and you'll be able to use that during tests. So the only ones that you'll have to remember are the 5.1 identities. Maybe let's write ourselves a little note here on the side. The only ones that you have to memorize are the 5.1 identities. Now, the reason I want you to memorize these ones and not the rest of them is the ones from 5.1 are really fundamental to this course, and you will without a doubt use those identities in every physics or math course you take after this. Okay. Now the ones in 5.2 and in 5.3 and soon to be in 5.4 here, some of these you'll definitely see again, but you won't necessarily be expected to have memorized them. You just need to know that they exist and that you know how to use them. Okay. So let's see here. In this example, we are asked to use a half angle formula. So if we went up, scrolled up, is what we would find this half angle identity. we would have sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha all over 2. All right. So next we need to use this thing. But before we can use it, we actually need to know one thing. What quadrant does alpha over 2 lie in? All right, so alpha over 2 is that 105 degrees. And so the question really is, what quadrant does this lie in? Well, 105 degrees lies in quadrant 2, which means sine will be positive. There we go. And again, the whole reason we're thinking about that is that means that sine is positive. So maybe we could even get rid of this, and maybe I'll just put the sign here in blue so that we know why it's positive. All right, so next is actually the hard part here. So this one's going to involve quite a bit of simplification. So if we start this off, I'm going to start as far over here really as I can. So sine of 105 degrees is equal to the positive square root of 1 minus cosine of alpha. Okay. Well, if alpha over 2 is equal to 105, then if you double that, you would get alpha. So alpha would be 210 degrees. Okay. So 210, and then all over 2. Well, if we look at our unit circle, cosine of 210 degrees is minus the square root of 3 over 2. So we get 1 minus the negative square root of 3 over 2. And then this is all over 2. All right, and then we can add those together. We'll get the square root of 1 plus the square root of 3 over 2. And then this is all over 2. And so what's going on here is we have a fraction that is part of another fraction. So to try and clean this up a little bit is what we're going to try and do is get rid of the fact that we have a fraction in another fraction. Okay. And so in order to do that is what we're going to need to do is actually add the 1 and the square root of 3 over 2. And so to do that, we'd need a common denominator, right? 1 is just 2 over 2. So this becomes 2 plus the square root of 3 over 2, and then that's all divided by 2. And if we keep going, well, if you take 2 plus the square root of 3 over 2 and you divide that by 2, then this becomes 2 plus the square root of 3 over 4. Okay. And if you wanted to, you could go even further with this, okay, because we know what the square root of 4 is. So you could rewrite this as the square root of 2 plus the square root of 3, and then the square root of 4 is 2. Okay. And so this is our final answer here. But I do want to point out, if this was an exam, I would be completely okay with you having stopped at this step right here. Okay. This extra simplification, I think, is important to be able to do, but that's not what I want to be testing you on test day.